Okay, this video starts off our unit on polynomials for topic 3, and we're going to talk a little bit about polynomials and then graph them a little bit. So the first thing we need to understand is what standard form of a polynomial is, and that's when we write it in descending order, okay, which means it's going down, so you're going big to small. And when we're talking about big to small, we're talking about the exponents. All of these are individual terms. So to write it in standard form, we have to rewrite them with the biggest exponent first. So the first one we're going to write is 4x to the 6th, and then minus 10x to the 3rd. Next would go 8x squared plus 7x minus 11. Once you have it in standard form, you can identify the leading coefficient. The leading coefficient is the number in front of the polynomial for the first term, so that would be 4. The degree is the highest exponent, which in standard form it should be first, so it's 6. The number of terms. The terms are separated by plus and minus signs. So we have 1, 2, 3, 4, 5 terms for this polynomial. All right, let's do the same thing on number 2. So in standard form, the one with the highest exponent has to go first and then on down the line. So we have 8x to the 5th minus 4x to the 3rd minus 3x plus 6. The leading coefficient is the number in front of the first term, which is 8. The degree is the highest exponent, which in standard form comes first, so it's 5. And then the number of terms would be 1, 2, 3, 4. Okay. The next thing we want to do is decide whether what the end behavior of the graph looks like. So what does it look like on the left and what does it look like on the right? Is it going up or is it going down? So they could both be going up. You could have one up and one down. It could squiggle a lot. It could be like this, but you got different combinations. Oops, I was trying to make one going down and I made it going up. Okay, so there's all different ways these graphs can look. And if we look at the degree of the polynomial and also the leading coefficient, we can tell. Anytime the degree is the same or even, the end behaviors are going to be the same direction. So that means that they're both going to open up or they're both going to open down. Well, how do we tell which one's which? Well, if it's positive, they're both going to go up. So that's like here and here. Okay. If they are negative, they are both going to be opening down. Okay. Example of that would be here. If it is an odd degree, well, they can't be going the same direction. They have to be going different directions. Okay. Well, how do you know which direction is which? Well, positive means up again, but from left to right, it's going up. So on the right, it has to end up. So if it's got to be going different directions, on the left, it's going down. So an example of that would be here or here. And last but not least, odd degree means different direction. And negative means it needs to be going down, but it's got to end down on the right, which means it's got to start up on the left. And I managed not to do one of those. So something like this. All right, so now let's look at some polynomials that are all in standard form and see if we can figure out their end behavior. And to do this, we're going to make a little chart with our notes. We're going to look at a couple of different things. Okay, we're going to look at the degree. We are going to look at the leading coefficient. And we're going to determine, based on those two things, the end behavior. So we're going to use this chart to figure it out. Okay, so if I'm looking at the first one, because it's in standard form, the degree is the highest number, which is 5. That is an odd number. So when it's odd, I'm in the right two categories. They're going different directions. The leading coefficient is that negative, so -1, which is a negative number. So when it's negative from left to right, it's going down. So on the right, it's got to end down, which means it's got to start up on the left. On the second one, the degree is the highest exponent, which is 4, which is even, so they have to be going the same direction. So now we're in the left two categories. The number in front, leading coefficient, is 7, which is a positive number, which means they both have to be going the same direction, and they're going up. If you look at this one, the degree, the highest number, or exponent, is 6. That is an even number. The leading coefficient is a -1, which is obviously negative. So because it's even, they're going, that's the left two, same direction, and because it's negative, they're going down. All right, so let's try putting this all together. So on this one, if we put it in standard form, highest exponent first, so we have 9x to the 8th minus 3x to the 4th minus 6x to the 3rd plus 4x. So the leading coefficient is the number in front, which would be 9. The degree would be 8. The number of terms would be 1, 2, 3, 4. For the end behavior, because the degree is even, they have to be going the same way. Because this is a positive number, they both have to be going up. All right, next thing we're going to do is try and graph it. And to graph these, and this is just a sketch, so this is not an exact picture, this is a sketch. But to look at these, we need to, we're trying to use this information to graph it. So there's two things that we need to identify, the x-intercepts and the turning points. Well, negative and positive intervals. Positive is above the x-axis and negative is below. So when it crosses the x-axis, it's going to switch from negative to positive. So when it crosses it, it's going to give us an x-intercept. So this information gives us our x-intercept. And when we graph them, we're going to graph them as points. So how do we find them? Well, we're going to use either the negative or the positive and copy down all of the numbers that are not infinity. So I'm going to have -5, -1, and 3. Because they're x-intercepts, it's going to be an x or a number comma 0, so they're going to look like that. Now, if I had to use the positive interval, -5, -1, 3, it's the same thing. It doesn't matter which one you use. Okay, so let's graph those. So I've got -5, -1, and 3. Okay, so increasing and decreasing is when it's going up or going down. So at these intervals, it's going to be changing directions. So this is my turning points. And when I graph these, I'm going to graph them as dashed lines. So I'm going to have a line, I'm going to use my numbers at -3.5 and 1.25. And again, I can use increasing or decreasing because it's the same numbers. I just ignore the infinity. So now I'm going to draw a line at -3.5, which would be in between -3 and -4. And I'm going to draw a line at 1.25, which is going to be in between 1 and 2. Again, it's a sketch. This is not going to be exact. Okay. My graph is now going to weave in and out. It's going to go through the points and change direction at the lines. But I need to figure out where to start. And so I'm going to start on the left, but I got to figure out on the left, is it above the x-axis up here or below the x-axis down here? So the way I look at it is I need to know what's happening out here to the left, which is at -infinity. So I'm going to find -infinity, and at -infinity it says that it's negative, which means it's below. So I'm going to start below, go through my point, turn at the line, go through my point, turn at the line, go through my point. And there is my graph. And the reason I knew to start it below was because I looked for the -infinity on the left, and it said at -infinity it was negative. Now if you need to check anything out, it also says between -1 and 3 it's negative. Well, between -1 and 3 it's negative down here. It says between -5 and -1, it's positive. Well, it's positive up here. These are all correct. Let's try it again. Okay, the positive and negative intervals, those help us figure out the x-intercepts, and when we graph them as points. You can look at either the positive or the negative, but you're going to read all the numbers that are not 0. So I have -3, -2, 0, 2, or 3. They're x-intercepts, so I'm going to write them as an ordered pair, some number, comma, 0. Okay. These, the increasing and decreasing, tell me my turning points. When I graph these I'm going to graph as dashed lines. Okay, and I'm going to list all the numbers that are not infinity. So -2.67, -1, 1, 2.5. Okay, let's graph the points. So we have -3, -2, 0, 2, and 3. We're going to have a line at -2.67, so in between -2 and 3. A line at -1, a line at +1, and a line at 2.5, which is in between the 2 or the 3. Now, when we start, because we're in America, we're going to go left to right. So we have to figure out what is happening in the left out here at negative infinity. So I'm going to look at my interval. Negative infinity is right here, and it says it's positive. So that means negative infinity, it's going to start above. So I'm going to start above, go through my point, turn at the line, through my point, turn at the line, through the point, turn at the line. And I'm going to keep continuing till I weave all the way through. And I can check any section along the way, and it's going to either fit increasing or decreasing, and it'll fit positive or negative.